Welcome, everybody. Time together around the telescope tonight as we take a peek at the king of the planets tonight. You'll have to excuse me. I'm getting over the flu, and so hopefully I don't cough or sneeze on you, but that might come about. Just so you know, just so you're warned. We're going to begin our journey with the largest planet in the solar system today. That's called Jupiter. It's a gas giant so immense and strange that even scientists are still unlocking its secrets and will be for quite some time. Let's dive first off into some just really amazing astronomy facts about this cosmic heavyweight. Jupiter has a radius of 69,911 kilometers. That's 43,441 miles. It's the biggest planet in the solar system. In comparison, the next biggest, which is Saturn, Saturn has a radius of 58,232 kilometers, or 36,184 miles. Jupiter is also the most massive planet. It's more than twice as massive if you were to combine all the other 7 planets together. Jupiter is twice as massive as all of them put together. Jupiter's size compared to Earth is such that it would take over 1,300 Earths just to make up the size of Jupiter. You can see that as I scroll down here. You can see it would take 1,300 Earths to make a Jupiter. Jupiter size, if you think about it, if Jupiter, and I used to do this when I taught 6th grade many years ago, if Jupiter was a basketball, Earth is the size of a grape. And I guess I could have had that ready. I should have thought about that and demonstrated that. But think of it that way: a basketball to just a grape. Okay. What is Jupiter? Unlike Earth, Jupiter does not have a solid surface. Instead, its atmosphere gradually becomes thicker and denser the deeper you go, eventually transitioning into liquid layers surrounding a small, mysterious core. You can see here you have upper clouds, gaseous hydrogen, liquid hydrogen, metallic hydrogen, and then you get to the core. Its composition is mostly hydrogen and helium. It's very similar to composition of the sun, and in some cases, some people have called it that Jupiter's almost a failed star. Anyway, it's been there. I know in what was that? 2001: A Space Odyssey. Jupiter becomes a star, I believe, and so anyway, he based it kind of off that premise. Little fun fact that's not in here. Fast spins and long years. Although it's huge, Jupiter has a surprisingly very short day. It completes one rotation in just about 10 hours. Sorry. That rapid spin causes the planet to bulge at the equator. One Jovian year, the time it takes to orbit the sun, is nearly 12 Earth years, though, because it's so far out. The Great Red Spot is a storm that seems to never end. One of Jupiter's most iconic features is the Great Red Spot. It's a gigantic storm bigger than the Earth. It's been going on for centuries. Wind speeds there can exceed 400 kilometers per hour, and it creates a swirling vortex visible from space. I've actually observed that many times, and I've observed Jupiter through my telescope, especially my larger ones, the 10, the 14, and the 17 and a half. The storm has amazed astronomers for generations, and it continues to evolve, and it's continuing to shrink over time. You can see here is December 1973 from Pioneer 10, and then the Hubble Space Telescope got it in June 2019. You can see it is shrinking and contracting. You can Google that. NASA has some really nice images of that. Moons, rings, and a mini solar system around it. Jupiter doesn't dominate the planets. It's also a miniature solar system of its own. It has 95 moons orbiting it, the largest, Ganymede, being the biggest moon in the entire solar system, outsizes the size of Mercury. So Ganymede is bigger than Mercury, one of the 8 planets. Some moons, like Europa, may have hidden oceans beneath their icy crust. Some debate on that, raising exciting questions about potential habitats for life beyond Earth. We know that there's 4 main Galilean moons. When Galileo looked at Jupiter, he saw these 4 moons and named them. They're named Io, Europa, Ganymede, and Callisto. So when we talk about these moons, things kind of get wild really quickly with it. Take Ganymede, for example. It's actually bigger than the planet Mercury, which I've mentioned, making it the largest moon or natural satellite in the entire solar system. And this just isn't a big rock drifting through space. Ganymede has its own magnetic field, which is incredibly rare for a moon, and scientists believe there may even be a hidden ocean beneath its icy surface. Then there's Europa, a little bit smaller than our moon, about 90% the size of our moon. It's one of the most exciting places in the solar system when it comes to search for life. Beneath Europa's thick shell of ice is strong evidence for a massive global ocean. Again, some debate on that. And it may contain twice as much water of all of Earth's oceans combined. NASA's Europa Clipper spacecraft is already on its way right now, set to investigate whether Europa truly has conditions needed that could support life. Io is next. Io is a completely different beast. It's slightly larger than our moon, but it's mostly volcanically active. It's the most volcanically active object we know. Io's surface is constantly being reshaped by more than 400 active volcanoes, some of them blasting materials hundreds of miles into space, and that's been recorded. It's extreme, it's chaotic, and it's absolutely fascinating. People build their careers in astronomy just on studying Io. And finally, there's Callisto, roughly the same size as Mercury. Callisto is the third largest moon in the solar system. Its surface is like a cosmic punching bag. It's the most heavily cratered surface we've ever seen. But even there, beneath all that ancient damage, scientists think there could be a subsurface ocean of liquid water tucked away under its icy crust. 4 moons, each of them entirely a different world compared to the other ones. The other thing about Jupiter, and we'll get to the ring system in a minute, Jupiter is critical for us. Its gravity is so massive that it pulls asteroids that technically probably could be earthbound and captures them or flings them out so that they don't come into the inner solar system and bang into us. So Jupiter plays a major role in that. Jupiter, most people don't know this, has a faint ring system, although it's nowhere near as spectacular as Saturn, nor can it be observed with amateur telescopes. You're not going to see it. I'm not going to see it with any of my scopes. Even somebody has a 30 or 48 inch, they're not going to see it. It takes the large earthbound telescopes to see it, or those in orbit around the Earth, and it really needs it to where Jupiter is flying in front of the sun, eclipses it, and then we can see this, as you can see from this NASA image from the Hubble Space Telescope. Jupiter is blocking out the sun, and that's how we're able to see the faint ring system of dust that's around Jupiter. Jupiter has the strongest magnetic field of any planet in our solar system, millions of times stronger than the Earth's. This powerful magnetosphere traps charged particles and creates spectacular auroras at the planet's poles. We think we have good auroras. Jupiter has fantastic auroras. Its gravity also influences countless asteroids and comets, which I've mentioned, including the mysterious Jupiter Trojans. These are asteroids sharing the planet's orbit around the sun, probably captured by its gravity. It's a target of exploration. We've been sending spacecraft there to study it up close for decades. Missions like Pioneer, Voyager, Galileo, and more recently Juno have revealed stunning details about the planet's atmosphere, magnetic field, and moons. Future missions such as NASA's Europa Clipper will focus on Jupiter's icy moons, searching for clues about hidden oceans and potential life, and just seeking to expand our knowledge of the Galilean moons that are out there. So, Jupiter is high up in the sky right now. It's up all evening. It makes a wonderful target, whether the moon's up or not. When the moon's down and I'm doing deep sky observing, it's the last object I look at the night, and it's probably good because then it's higher up up towards zenith, so I'm looking through less atmosphere, and that allows me to get actually even crisper and more wonderful views of the bands on Jupiter. So anyway, if you get the time this season, over the next several months, take some time to look at Jupiter. The other thing you can do is watch for transits on Jupiter's moon. The four Galilean moons will actually go in front of Jupiter, and they put a little black circled dot on Jupiter. I've seen it many times. Usually, the first time an amateur sees it, they think something's going on. It's not. It's a moon shadow from one of the Galilean moons that are doing that. If you Google, and I'll try to see if I can put a link in here, you can get transit times and actually look at those shadows as they go across. It's kind of a fun thing to do if you're taking a look at Jupiter. Anyway, look up. I hope you have a wonderful day. I hope it's clear where you are. It's still not clear where I'm at. And we'll talk to you later. Thanks for gathering around.